This is Year 6 Maths for Monday the 8th of June, and the learning objective is I can use my knowledge of factors and multiples to solve problems. Good morning Year 6, I hope you had a really good weekend and welcome to Maths for week 2 of term 6. So we're going to do a bit more work on ratio and proportion this week, moving on to doing some scaling. But before we do that, we're going to do a recap lesson today looking at factors and multiples. So here's a starter. Take a look at the numbers 12, 42, 36, 72, 40 and 54. Pause the video and have a think about which of those numbers you think is the odd one out. When you are giving your reason, try to use some mathematical language in your explanation. So words you might want to think about are factor, multiple, square or prime. There are different options you could go for. For example, you could say that 36 is the odd one out of those numbers because it's the only one that is a square number. A square number is where a number is multiplied by itself. So 36 is 6 squared. 6 times 6 is 36. Another option you could have gone for as the odd one out is 40. 40 is the only one of those numbers that isn't a multiple of 6. It's not in the 6 times table. So let's think a bit more about what we mean by factors and multiples. Your job is to pause the video and match the definitions to the words. The choices are a whole number that divides exactly into another whole number, an extended times table, and the numbers you multiply together to get another number. So you're going to sort them, which definitions go for factor and which definitions go for multiple. Okay, how did you get on? So for factor, the definitions are a whole number that divides exactly into another whole number. So for example, 2 and 6 are factors of 12. You can divide 12 by 2 and you get a whole number, which is 6. Another definition for a factor is the numbers that you multiply together to get another number. So for example, 2 and 6, you can multiply them together to get 12. For multiple, the definition is it's an extended times table. So that means that the multiples of a number are the numbers that are in its times table. So for example, multiples of 6 would be 12, 18 and 24. But multiples, you don't just stop at 10 times or 12 times like you probably would with your times tables. It can be any number multiplied by that number. So for 6, we could go for 600 or 6,000. They're still multiples of 6. So let's have a bit of a practice. Pause the video and in your book, write down the factors of 24. So let's check how you got on. Remember, when you find factors, we usually find factor pairs, numbers that you can multiply together to make the number, and we try to write them down in a systematic way so that you don't miss any of those factors. So every number has the factors 1 and itself. So for 24, the first factor pairs are 1 times 24. Then we can do 2 times 12 to make 24, so that's shown in the array there. If we move the dots along, instead of 1 times 24, we can have 2 times 12. And then if we rearrange our 24 dots again, we can make it into 3 groups of 8. So 3 and 8 are factor pairs for 24. And then finally for 24, we have 4 times 6 is 24. So 4 lots of 6. Now pause the video again and write down 4 multiples of 7. So probably the most obvious choices to go for would be the first numbers in the 7 times table. So 14, 21, 28 and 35. But remember, multiples aren't just the numbers in the times table, it's the extended times table. So you can go beyond 10 times, you could do 100 times the number, so 700 is a multiple of 7. You could have 133, which is 19 times 7. So any number multiplied by 7 would be a multiple of 7. So here are your activities for today. This is a game that we've had a go at already in class this year, but it's a good reminder of factors and multiples. You need a 100 square grid, you can use the one on the right. And as you choose a number, you need to make a record of it and write it down so that you know you've used it. If you can print out the grid, then you could cross it out on the grid. Then you choose a second number. Your second number must be a factor or multiple of the first number. So for example, if I'd chosen 20 as my first number, I could go for 10 as my second number because 10 is a factor of 20. So the challenge is to carry on crossing out numbers at each stage, choosing a number that is a factor or multiple of the previous number that has just been crossed out. And you need to try and find the longest sequence of numbers, factors and multiples that can be crossed out on the grid. And each number can only appear once in your sequence. So I've started making a chain here. I started with the number 10, so I've written it down in my sequence and I've put a blob to cross it out on the grid. Next I've gone for 40 because 40 is a multiple of 10. 4 times 10 is 40, so I've put a blob over 10, a blob over 40 and I've written 40 as my next number. Next I've gone for 8 because 8 is a factor of 40. 5 times 8 is 40, so I've put a blob over 8, that's my next number. And then after that I've chosen 64, put a blob over 64 and added that in. 8 times 8 is 64. So I'm going in a chain, factors and multiples, and I'm going to see how long I can carry that on. So once you've spent some time on that first task, there's another new problem for you to have a look at for today. This one's called factor lines. So your task is to arrange the 4 number cards, 1, 2, 3 and 21 on the grid, and you're trying to make a diagonal, vertical or horizontal line, a bit like you do in noughts and crosses. But you can only put a number card on a square with either a multiple of that number or a factor of that number. So for example, I decided to start by placing the 21 onto the grid. And I looked at the numbers on the grid to find either a factor or multiple of 21. I know that 1 must be a factor of 21 because 1 times 21 is 21. So I've put my 21 over the 1 on the grid. Next, I was looking to place my 3 on the grid. So I looked for a number that would be a factor or multiple of 3. I know that 6 is a multiple of 3, so I put the 3 over the 6 on the grid. So I'd carry on to try and place my 2 and my 1, and I'd be trying to make them into a line. So here are some questions to think about. Which of the cards 1, 2, 3 and 21 can be multiples, and which can be factors, and can any of them be both? I think they can be both. For example, 3 is a multiple of 1, but also a factor of 6. Are there any numbers on the grid which are impossible to cover? If they are, why or why not? And of the numbers 1, 2, 3 and 21, which is going to be hardest to place on the grid and why? Which of the 4 numbers will be easiest to place on the grid, do you think? And are there any strategies you could use to solve the problem? Thinking about which numbers would be easier to place, I know that 1 and the number are factors of every number. So for example, the factors of 6 are 1 and 6, the factors of 7 are 1 and 7, factors of 8 are 1 and 8. So it's going to be quite easy for me to put the 1 onto the grid. It's going to be much harder to put the 21 onto the grid. There aren't any multiples of 21 to choose. The first multiple of 21 would be 42, and that's too high to be on the grid. So I'm going to be having to look for factors of 21, and there aren't so many choices for factors of 21. So my strategy could be to try and place the 21 first, because there's only a limited number of places where I can put that card. So once you've managed to arrange the numbers 1, 2, 3 and 21 into a line on the grid, your challenge then is to see how many different lines you can make on the grid. Remember to think about how you're going to record your work clearly. There's a copy of the grid on the website if you can print it out, or you could draw yourself a grid in your book if you need to. When you think you've found all the possibilities, have a look at the website where there's a copy of the solution.